Hello, this is Mike. Welcome back to BitFixer. Today we're looking at the TRS-80 Model 1 for Septandy. Last time, a few weeks ago, I looked at this computer using the ROMulator Z80. We were testing out some of the features of the ROMulator, which is a RAM and ROM replacement device for a Z80 microprocessor, which also has some debug capabilities. And we discovered some issues with this computer. There are multiple faults with the display, as well as a what looks like a known ROM fault of some sort. And today I wanted to get this computer fully working so we can play with it further. If you haven't seen the previous video where I used the ROMulator to test out this TRS-80 Model 1, I would recommend checking that out. There'll be a link to it in the description. So let's have a look. But first, a thank you to PCBWay for sponsoring this video. PCBWay is a one-stop shop for PCB fabrication and assembly, as well as a number of other things like CNC machining, injection molding, 3D printing, and sheet metal fabrication. And new members get a $5 coupon to use on their first order. Thanks to PCBWay. Quick recap from the last video. The first problem with the computer is the video output. Here you can see a video signal that won't sync. After looking at the schematic for the sync and video signals, trace down the problem to the 74C04 chip at position Z6. I replaced it with the 74LS04 chip, which is what I had on hand, and it seemed to improve the signal, but there was still something wrong. It looked blown out and couldn't adjust the horizontal position on the screen. Then, to test further functionality of the computer, I replaced the RAM and ROM with the ROMulator, and then we see what might be a corrupted startup message, so possibly another display issue, maybe video RAM. And then using the virtual display function on the ROMulator, we can see that the computer is actually starting up and it's writing the proper values into video RAM. So we just have a display issue and we probably have a ROM problem. This time I'm going to start by looking at the sync problem on the video circuit. So I had replaced the 74C04 with the 74LS04, which is a different logic family. So I decided it would be a good idea to try to find a real 74C04, which are actually pretty hard to find. But I did find a 74HC04, which is high-speed CMOS. So let's give that a try and see if we get a better result on the video output circuit. Okay, I now have a 74HC04 in place, and let's see what happens. Before we had that page of text that wouldn't sync. Okay, look at that. That looks pretty good. It's off to the left a little bit. With the LS, the text was all the way over to the right, and we saw that the H-sync was still a bit messed up, but now this looks pretty good. Now we can try the potentiometer. That is probably the adjustment for where the line starts. So let's just try to adjust that pot and we'll see what happens. I'm going to adjust the potentiometer here to see if we can move the picture. And we can. Okay. So this appears to now be working as intended. Interesting. So yeah, the LS was just not the right replacement for that 74C04 chip. So that's a good thing to know, and something I've learned in doing this. But that looks like one problem solved. After replacing this 74C04 with the 74HC04, now we have the composite to HDMI converter is able to sync on the picture again. And now you can see that we have sort of a coherent, looks like a coherent image, but some of the characters have little dot errors here. And that is making me think about video RAM. But the video RAM is right here on the board. There's 6 of them, 6 2102s, 1, 2, 3, 4, 5, 6. And we can attempt to do the piggybacking trick, where we stick another chip right on top of it and see if it improves the picture when we do that, or if it changes at all. So I'm going through these 2102s one at a time and trying to piggyback the new chip onto each one. I didn't see much difference until this one here. So let's just look at what this is without the new chip. With the, it's like you have exclamation points. It's actually at the top region you have what looks like exclamation point 9, and then the rest of the region That's maybe a period, I guess. So different character. Let's try piggybacking the chip onto this one. Let's make sure that get a good connection between every pin on there. Make sure it's facing the right direction, of course. And now let's see what we get on the screen. I'm just kind of holding the chip in place there. And that looks quite a bit different. You see the top region no longer has the exclamation point there. If they were both good chips, you wouldn't see any change. And it's possible that the new chip is bad also. I should just double check this chip to make sure that it's good. But I would say this is a pretty strong indicator that this is a bad chip and we should replace it. There may be something else going on too, because I see little dot glitches going on as well. But probably worth replacing this chip first and then see where that leaves us. I decided to skip ahead just a little bit and use the ROMulator again on the board, just because at the moment we know we have a ROM problem, and instead of getting something coherent on the screen, we're getting this pattern with the 9s, and I just figured if we have a actually working ROM, then we'd be able to more easily see what's going on. So at the moment, with the ROM replaced, we get the message that we saw last time. And I know that's trying to say memory size, but there's possibly a bit wrong, a bit off, that's making it write that instead, write those characters. So I'm just going to try to, I'm guessing that there might be a second 2102 that's bad as well. So before I'm actually going ahead and replace, I've left this one in the piggyback spot, and I'm just going to try some other chips to see if that makes any kind of difference. So I tried them one by one, and I didn't see any major difference except for this one here, which had fairly big difference. So let's put that in there again and power up. And this time, let's see if it does the same thing. Oh, ooh, okay, wait, turn it off. That can happen. Just slipped off of there. Hope I didn't do anything bad. You should be more careful than that when you're trying this. All right. Okay, yeah, there you go. And the top line now says memory size, which is it's supposed to do. That is giving me pretty strong indication that at least those two chips are bad. So we have two 2102s to potentially replace here. So for the record here, the chips we're replacing are Z48 and what's this one? Z62. So let's go ahead and replace those, and then we'll get a better idea of if that's the only problem with the video or if something else is going on. Okay, I have finished replacing those chips. We have this and this chip here. The 2102s have been replaced. I actually made a little mistake here, and I accidentally removed this chip as well, which is just a logic chip, but you know, that can happen when you don't label the chips that you're trying to remove. I knew it was diagonal from this one, but somehow, you know, it's not paying enough attention, and I ended up removing this one too. So it has a socket now. Hopefully not a problem. I don't think I damaged anything, but you know, label your chips when you're taking them out is the lesson I learned. So okay, let's try it out. Hopefully we'll see some change in the display. Alright, look at that. So we get the memory size message. It looks intact, and I don't see any other, well, except for the obvious issue with the dots on there. The characters look to be alright. So, and as you can see, it looks like every space here we have a single dot. And that, I'm guessing, is going to be some kind of stuck bit. It looks like one of the bits, when it's reading out from the character ROM, perhaps is stuck high. That I don't think is a video RAM problem. The video RAM would really just provide an index into the character generator or the character ROM, and that appears to be okay. I think that it's perhaps the character ROM itself, or I think more likely something between the character ROM and the actual video display outputs. Not too surprisingly, this character generator ROM is not directly supported by my ROM reader, so I had to rig up a little makeshift adapter here. Unfortunately, I had this thing, this is a 40-pin dip, I guess, relocator board that I use for the ROMulator, where you can put it in a CPU socket. You can connect a 40-pin ribbon cable and then shift it somewhere else if there's a physical constraint. But right now I have it in the ROM reader, and I've connected up the pins here on a breadboard. And the closest ROM here was a 27C16 that was supported by the ROM reader, so I've just hooked it up. And what I'm going to have to do is there's an address line that's not used, so I'm going to have to chop off the top half of the ROM when I get the reading, and then there are 3 data bits that are also unused. This is, that's 27C16 is an 8-bit output, but the character generator only has 5-bit output, so I will just mask every byte of the output to zero out those top 3 bits of each byte, and that should give me a good read of the character ROM. Using the little utility I wrote, I was able to render out every character in the character ROM to a bitmap here, and interestingly enough, you can see that on the characters where I see the little dot, like a space, there is a corresponding dot in the character ROM itself, like the T here, the V. So this leads me to believe that it's the character ROM itself that is at fault. So there's bad bits here and there in the contents of the ROM. So that is, I guess it's not something I have to deal with at the moment, but I can burn another ROM for it to replace it, and that would take care of the problem. And I'm writing a new EEPROM with the valid character ROM data. And next we will wire up a socket adapter so that the new ROM can fit into the character ROM. This over here is the pinout for the MCM6670, which is used in TRS-80, and then this is the new chip I programmed, the 28C16. So it looks like maybe we can map these mostly the same, but then there's a lot of difference over here, so we're going to have to run some wires around. So hopefully I will probably get a PCB made of this, but for the purposes of this fix I'll just wire something up on a proto board or something. Well, this is far from beautiful, but hopefully it will do the trick. This is our 28C16 here on a breadboard, and I've wired up a socket, 18-pin socket. Where is it? There it is. 18-pin socket with the appropriate connections to the character ROM socket on the TRS-80. So let's see if I just wasted a lot of time or this thing works. Alright, look at that. Memory size. And we no longer have the dots on the spaces, and it's looking good. Yeah. I see, remember the parentheses had little dots on them. Oh, that's enter. What am I doing? Yeah, it's looking good. While I will replace that with an actual PCB eventually, that is a successful character ROM replacement. Well, I couldn't really abide that last mess of wires, so I made this other version of it here on proto board. It's not the best looking still, but does still do the job, and I will replace that with a real PCB as soon as I get the chance to make one. And yeah, we have a working screen. So next up, let's look in to see what's wrong with the ROM. I think that might be the last remaining issue. So taking a look at the ROMs here, this may be a very quick fix. This ROM looks barely in its socket. It doesn't even look like it's in the socket at all. So let's try reseating that. That looks like a pretty strong candidate for the problem right there. I've got a bent pin. So we'll try to take care of that and get it back in the socket here. So with that ROM reseated and the Z80 is back by itself without the ROMulator, so let's test if that ROM is now working or not. Okay, no. So ROM is still bad. We'll get that pattern again. And I guess we will read, let's try reading in these ROMs to see if it matches up with the known contents. Well, I am reading in the ROMs on the level 2 ROM upgrade board here, and the first two would not read, but the third one came up to what looks like valid data. I even see some text in here. Oops, that's not right. I see some text, yeah, extra ignored. So this looks like it's probably valid data. So I'm going to save this. I'm just going to try those other ones again. But the first time I read them, they came up as all FF, which could explain why we're seeing that that pattern on startup with the bad ROMs. I'm just comparing the ROM image I have for the version 1.3 ROMs that's programmed onto the ROMulator here, and then this is what I've read from the ROM on the actual board. This is the one that actually had some data, and it starts with 2D38.021E, and I found the same position in the original 1.3 ROM 2D38. So this ROM presumably is starting at address 2000 hex. So we're missing, looks like we're missing 2 out of 3 of the basic 2 ROMs, which would explain why we can't boot up. So I guess the next thing is, I'll see if I have enough. These are 2716 ROMs, and I think I have 2 more of the 28C16 EPROMs to replace them. So I will check to see if I have enough, and we'll see if we can get a replacement in. Okay, well, thanks to some helpful folks on the VC-Fed forum, I think I understand what the deal is now. I think the level 2 ROMs on this Model 1, when it comes in a 3-chip set, these are 2532 instead of 2732, and that's a separate pinout from TI, and those are not really available anymore. So I may have to just wire up something to adapt it to a 2732, which the ROM reader can handle. So it looks like the difference is that pin 21 is not A11. Actually, pin 18 is A11. Okay, so the enable, let's see, where's enable on this one? Maybe there is no enable pin on the 2532. Okay. So it looks like we can just not connect enable, and we just swap the A11 down to pin 18, and let's see if that works for us. All right, let's try this again. I was doing the wrong thing before. I was clipping onto the pin of the chip itself as opposed to the pin from the socket. So this is A11, and now I'm connecting it to pin 18 here. So let's try this again. That actually looks good. I don't see any big blocks of FFFF, so that may be a good read. So after reading all these ROMs, it is sort of looking like the third ROM that I thought was good the first time may actually be the culprit. So what I'm going to do is I'm writing 2 copies of the contents of what should be there to a single file, and then I will write that to a new EPROM, a 27 or 28 C64. Alright, another attempt. I have the same ROM. I think the adapter I had before was slightly wrong, so made another attempt, and let's see if this one works. Switching on. Oh. Okay, so not quite. Well, thinking about it for a moment, I realized I was making things a little bit overly hard on myself. It was possible to, using the ROMulator, I could selectively enable each of those ROMs on the board. So I went ahead and set up 3 more configurations. Each of these is passing through one of the ROMs selectively. So I'm going to write that to the ROMulator, and and we'll just give it another try and see if any of these ROMs are actually good. Okay, I've configured it to pass through the ROM at address 0, from 0 to 1000 hex. And if this works, that was a good indicator that that ROM is good. So let's turn it on. Okay, get garbage there. Interesting. So even that one is not working. So let's switch it to the next setting. There we go. So that's the next ROM. I have a feeling, yeah, it looks like we're going to get the same result. That is actually the same screen we saw when we replaced the ROM with the one in with the new EEPROM. There. Ooh, well that's different. Let me turn it off. So if I individually enable each ROM, it still doesn't work. So that could be something to do with maybe the cable itself or the sockets on that level 2 ROM board. And to save a little bit of time, I'm going to give you a montage of some wrong turns I took. At first, I suspected this 74LS156, which was connected to one of the wires on the ROM board. Ran down to Jameco and got some replacements, but unfortunately that did not work. And then I suspected the 74LS42 chip on the ROM board itself, which looked like it wasn't properly selecting the individual ROMs. Okay, some time has passed, so let me explain exactly what happened. So as you can see, I took the L2 ROM expansion board and removed it from where it was stuck on the back. That took some effort, removing nearly 50-year-old adhesive from the board, and I socketed this chip here, which is the 74LS42, the binary decoder, and I tried replacing it with a new one, actually 7442, that I got from the Digital Group computer, because these chips were a little hard to find. And zero change, nothing happened at all. It was exactly the same. All the select lines for the ROMs were all stuck at 0 and nothing was happening. And so spent some time poking around different parts of the board, really finding nothing, until finally I checked the VCC power line on the 74LS42, and it was 0. There was no power. So how could that be? And it turns out that in doing all this checking, I had never actually really verified that this ribbon cable was okay. And it turns out that pin, I guess it's pin 24 on this ribbon cable, is actually broken off. You can't, I don't know if you can really see it here, but the pin is actually stuck into the socket and not connected to the connector part here. And I had not even removed this cable until just recently when I took the L2 board off. So that was a little bit of a face-palming kind of moment, because basically just no power was getting to this board. So that would explain almost everything. So what I've done here, and I'm just about to wire it up and we'll test it, but I have line going to a place where 5 volts exists, and I'm going to just clip it on to the VCC pin there. And let's power it up and see what happens. Okay. And let's see. Actually, you know what? I will just quickly show you what configuration we're in before powering up. ROMulator Z80 is in. I'm on setting number 2, which is the 1.2 ROM replacement and RAM replacement. And I have manually switched 7 here. Just a little note on the recent firmware for the ROMulator. Switch 6, you can independently disable RAM, and switch 7, you can independently disable ROM just with one switch when you start up. So if you don't have that already, if you rebuild from the repo, you'll get that functionality as well. So I have switch 7 in the on position, which means we're going to disable anything that's configured as ROM. So right now it should be, if it boots up, it means that this ROM is working. So here we go. Okay, we're getting the screen. All right, look at that. We have the memory size prompt, and that means that this is booting up even though the ROM is not replaced. So As frustrating as it is, it means that the just the broken pin on the ribbon cable, that was the whole problem with the ROM. So presumably the ROMs are good. This is actually the original chip, the 74 LS42. That chip is good, and that 74 LS156 that socketed and replaced. This is the original chip as well. So that that chip as well is just fine. So just to confirm now, I'm going to power off, and let me turn off I'll turn off the RAM as well. So now we're in, it's bypassing all RAM and all ROM. So let's verify that it still works. Oh, okay. It doesn't. So does that mean, well, we had definitely checked that the RAM worked before, so does that mean that the RAM has since gone bad? Alright, I'm just going to do a little, let's see, cool. Let's see if I can tell if any of these chips are warming up. Oh, yeah, this one is warm. It's hot. This is a hot chip. Let's double check. It's not super hot, but that chip is definitely warmer than the others. Interesting. So that means that potentially, yeah, a previously working RAM chip, maybe it was on the verge of dying anyway. I think one of our RAM chips has gone bad. But fortunately, I have right here my Commodore PET 8032, and that has plenty of 4116 RAM chips in there, so I'll just borrow one and we will try again. Alright, I removed the ceramic 4116 and I will replace it with one of these plastic, is this the one? Yeah, this is the one from it has a different, it's not labeled as a 4116, but it is in fact a 4116. It was in the Commodore PET. So I will put that in the socket here and we'll give it another try. 4116 is socketed and ready to try. Everything else is exactly the same. We're bypassing RAM and ROM on the computer and it works. Nice. Alright. Yep. I'm just checking the chips for temperature again. It's not getting hot as far as I can tell. Well, good. That means that that means we have a completely working computer now. We do still have the ROMulator in place, so next thing, I'll just put the original Z80 back and we'll just verify that everything is now working. Alright, original Z80 back in place, and we have our temporary fix in place with 5 volt running to this memory board, the ROM board I mean. Let's verify that the computer can now run unassisted. And there we go. We fixed well, all the known problems. Haven't really loaded anything from cassette yet, but I think I'll save that for another time. But we have a working TRS-80 Model 1 now. And we'll summarize the things that we did to fix this. So first was it was a bad 74C04 hex inverter that I first replaced with a 74 LS04, and that somehow improved things a bit so I could see a stable picture, but it didn't really work. Then I replaced it with a 74HC04, and that in fact did work. There was a kind of an interesting little feedback loop that was going on in that part of the circuit. So let's see, so we had 2 different video RAM chips, 2102s, that were replaced, and then we got, at that point, once we had the replaced chips, we got a working screen, but it had some dots on the letters, and then went through this whole thing where we replaced the character ROM with an EEPROM, a 28C16 that I had around, and finally, after a lot of false starts and looking in the wrong place, figured out that the ROM board was not getting power through the ribbon cable, and It would be nice to fix this thing, but these sort of this style of connector where you have the ribbon cable and then it goes to dip pins, those are pretty hard to find now. So what I think I will do is I'm just going to solder a wire on the back of this and probably run it through the same tube where the other wires are going onto the board to get the address lines and such, and I will power it through that. That looks like about it for our repairs on the Model 1. Well, there is a little bit of an epilogue here. I did notice that there started to be some keyboard errors, and on closer inspection it looked like this ribbon cable was starting to deteriorate. So I ended up replacing the entire thing with some ribbon cables I had around. I'm not sure I did the best job on this, but it does seem to work. And I did finally get the PCB made for the character ROM. It looks like this will do the job. However, I did find out that this actually sticks up a little bit too high and it hits the bottom of the case of the computer. So for now I'm just leaving it unscrewed because it won't close all the way. But I think if I just move this this EEPROM down in this direction closer to where this capacitor is, that should give just enough clearance that the case can close again. And that's all for now. Thanks so much for watching. Let me know in the comments if you want to see anything more on this TRS-80 Model 1 or the ROMulator Z80, and see you next time.